Find the equation of the tangent to the curve y equals x squared minus 8x plus 16 at the point 3, 1. So to find the equation of the tangent line to a curve, we're going to need to find the gradient of the tangent line. And we know that the derivative gives us the gradient of a tangent at any point on the curve. So we first need to find dy dx, and that's just a notation that stands for the derivative. And we know the derivative is equal to, and for a polynomial, we just take the power out the front and subtract 1 off the power for each of these polynomial terms. So x squared, when we take the power out at the front, will be 2 times x to the power of, and 2 subtract 1 will just be 1, so that's going to be 2x. And then minus 8x to the power of 1, we take the 1 out the front and multiply it by negative 8, and then we subtract 1 off the power, and we'd have minus 8x to the power of 0, but anything to the power of 0 is simply 1, so this is just 2x minus 8. And we know the derivative of a constant will just be 0, so dy dx is 2x minus 8. Next, we need to find the gradient at the point x equals 3. So that means we need to evaluate dy dx at x equals 3, and we use this straight up and down line just to say that's where we're going to evaluate dy dx at. And this is just going to equal 2 times 3 minus 8, which is equal to 6 subtract 8, which is equal to negative 2. So the gradient of a tangent to the curve at the point x equals 3 is going to be negative 2. So next we need to find the equation of a straight line, and we can use the formula y take y1 equals m times x take x1 to do that, where m is the gradient, so for us m is equal to negative 2, and that's that value here. And we have a point x1, y1 that we know the line goes through, and that's going to be the point 3, 1. So that's what we're going to substitute into this equation. So when we do that, we'll have y take y1, which is y take 1, equals m, which is negative 2, times x take x1, which is 3. And now if we expand out the right-hand side, we'll have y take 1 is equal to negative 2x plus 6. And then adding 1 to both sides of this equation will give the equation of the tangent line is y equals negative 2x plus 7. So this is the equation of a tangent to the curve at the point 3, 1. Next, we'll use the calculator to find the same result, and we'll also have a look at what this means graphically. On the CAS calculator, go into the main menu. Next, what we want to do is type in the equation of the curve, which was x to the power of 2 minus 8x plus 16. Now if we highlight that and go interactive, calculation line, we can calculate the equation of the tangent line by pressing tan line. And we have our expression, we have our variable x, which is what we would derive with respect to, and we want this to occur at the point x is equal to 3. So we sub 3 in here. Pressing OK will give the equation of a tangent to the curve at the point x equals 3, and that is minus 2x plus 7, which is the same as what we found by hand. If we click on the graph icon, we could drag our curve equation down, which is a parabola, and what we can do is we could zoom out. So if we hit the minus key on the keypad, we can zoom out and we can drag this so that we can see all of the graph. And if we were to go analysis, sketch, tangent, this is another way to sketch a tangent line. And if we hit on the hard keypad 3, that will give an x value of 3 for where we put our tangent. And that gives us this line here. And if we hit the blue execute button, the equation of the tangent line appears down here, which is y equals minus 2x plus 7, which is the same as what the tan line command gave in the main screen, which is also the same as what we found by hand. So that green curve here on our graph screen is the tangent to the point 3, 1, and it has a line y equals negative 2x plus 7.